You ever manually built an EKS cluster and then spent hours trying to manually reverse engineer it into Terraform? Today we are ending that pain. I will show you how to import a live EKS cluster or any other resource and let Terraform generate the code for you. I am using LocalStack to simulate AWS locally. I have already manually spun up an EKS cluster with 2 nodes. Now we want to move this into Terraform management without typing hundreds of lines of resource block. Here is the import.tf file. We defined 3 blocks, one for the cluster and 2 for the nodes. We provide the ID of the existing resources and the address where we want it in our code. And we have the provider.tf file. Here we have defined the AWS provider and specific local stack endpoints. If you are using the real AWS cloud, you can ignore these extra endpoint lines. Everything else remains identical. Now let me run the Terraform init to prepare the plugins. Now let's run the Terraform plan with the flag generate config out. Terraform looks at the live state, compares it to our import block and write the actual Terraform code for us. Now we got the errors. Let's look into it and debug. This is a warning. Config generation is experimental. This feature rolled out long back, but still it is under experimental. It's not officially stable yet. LocalStack has some unexpected parameters like max unavailable percentage that the AWS provider is not expecting. If you are using AWS cloud, you won't get this error. I simply comment these lines for both node 1 and node 2 and rerun the plan. The plan now shows 3 to import, 0 to add, 0 to destroy. This is perfect. It means our code exactly matches the live infrastructure, but in real world scenario, it may not happen because of multiple reasons like the feature itself flagged experimental or any other dependent value or something. Let's assume if subnet block is not there. Let me remove it and test. Okay, subnet ID is mandatory. Now let me remove the versions and check. Okay, this is also not detecting. Oh, now let me change the subnet ID. Now you can see 3 to import, 1 to add, 0 to change, 1 to destroy, which means because of the subnet ID change, Terraform will recreate the demo node too. When you do the Terraform import, make sure you don't have any drift, else it will recreate the resource or it can destroy the existing resource. Now let me revert the change and apply it. You can see import is successful now. State file also created for cluster and the nodes. Now let's update something in the main.tf and see if the changes are working fine as expected. Now let me add a tag and apply it. You can see there are no tags currently to the EKS cluster. Okay, now it's applied. Here you can see tag is getting updated in the console. So we are good. Everything is working fine as expected. Currently, state file is storing in our local. In organization level or for best practices, we should not keep state file in our local. We need to use remote backend. It prevents team members from overwriting each other's changes. Without a shared backend, there is no source of truth for the infrastructure's current state. We'll use the state locking as well. It will prevent race condition. If two engineers run Terraform apply simultaneously, the DynamoDB lock ensures only one operation proceeds, preventing state corruption. Let me create a S3 bucket and DynamoDB. Here you can see S3 bucket is created and DynamoDB also up and running. Now let me update the provider.tf with the remote backend and state locking configurations. Here you can see bucket, path, DynamoDB table and the encryption. These are the required information, and the other details you can ignore. This is required as I am using LocalStack. Let me run the Terraform init command. Now you can see Terraform state file is copied from my local to remote S3 path. Now let's try some real world scenario like upgrading the EKS version. So now let me update main.tf with the new EKS version 1.33. This seems to be because of the LocalStack environment. If you are using AWS cloud, it should work perfectly fine. Let me check in the console what is the exact issue. Okay, got it. We don't have any EKS upgrade option in the LocalStack EKS cluster. So that's why we are getting error. We have successfully transformed from a manual ClickOps into a fully coded professional environment. If you want to see how to automate EKS upgrades using this exact setup on the actual AWS cloud, let me know in the comments and I will put together a full production level walkthrough.